Hey there, everybody. Today we're going to do a lesson on hotspots, focusing mainly on Hawaii, the most famous hotspot in the world. And on your Google Classroom assignment, you have this slideshow of notes called Hotspots Mantle Plume. So I'd like you to bring them up because there are some slides that I'm going to broadcast, but you have them blank. And as I bring up the notes, I need you to copy them onto your Google slide of the hotspots. And then once it's done, turn it into me. Okay? So the first slide says Hawaii Hotspot Explained. And the left picture is the Hawaiian Islands. Those are the Hawaiian Islands that make up our state. But actually there are hundreds to thousands of Hawaiian Islands. And they actually go all the way from the Big Island of Hawaii all the way to Alaska. It's crazy to think that Hawaii can run all the way to Alaska. But the geologic formation, not the state, known as Hawaii Emperor Seamounts, go all the way to Alaska, believe it or not. Okay? Now, if you know anything about Hawaii, besides being a tropical paradise, they are made of volcanic islands. So every one of those islands was once a volcano. But there's only one active island. There's only one island that is currently erupting. It's right here. We call it the Big Island. Okay? So the Big Island of Hawaii is erupting, and then all these other islands are extinct volcanoes. Okay, so they can no longer erupt. And they also, if you look, they get smaller. So what I want you to do is I showed you how to use the Google Keep. So I want you to bring that image into Keep, save the Keep, and then open in Keep. And now you can write on it a little bit to take notes on what I'm saying. So you can take notes on the bottom, or you can also click on the image and draw on it. So you can put labels. And that's what I want to do right now, is label it a little bit. So the island on the bottom right, okay, in the southeast corner, I want you to write down young. Sorry, I ran out of room. Let me clear that. Okay, we're going to write down young. And over here, you'll write down older. And then I just want you to draw an arrow from the biggest island to pointing towards the smaller islands. And what that arrow represents is what we call the direction of plate movement. So the Hawaiian Islands are moving from the southeast to the northwest. Okay? So the youngest island is in the southeast, and the oldest islands are towards the northwest. And they are in that direction because that's the way the Pacific plate is actually carrying them. The Pacific plate is actually carrying each island towards the northwest. So on a test or any question, if you have a picture of the Hawaiian Islands, just draw an arrow, just like I did here, from the biggest through the smallest. And that will actually allow you to figure out the direction of the movement. Okay? So now I'm going to present this a little bit. And the first video that's on here, this one is super. It does an amazing job explaining how a hotspot can form a volcano, and then how that volcano can move. And then you get a chain of islands, or an archipelago, which is a chain of islands. Go back. Sorry, should play. There we go.
Not all volcanoes form at plate boundaries. Some form instead in the interior of a plate, where geologists call them hotspot volcanoes or simply hotspots. One explanation of such activity is the presence of a mantle plume, a regionally restricted column of hot rock rising inside the asthenosphere. When it reaches the base of the lithosphere, the rock partially melts, sending intrusions of magma upwards into the plate. Some of this magma erupts to form active underwater volcanoes, or, if activity is sustained, an active volcanic island.
Okay, so that's what's happening right now on the Big Island of Hawaii. So the hotspot is this area in the mantle, called a mantle plume, that is extra hot than the surrounding mantle. So hot that it's continuously melting through the overlying lithosphere. So as the mantle comes up and melts through, and then it erupts, and that lava hardens into rock, and it builds up a mountain in the form of an island, or if it never reached the water, we call it a seamount, or mountain in the sea. Okay?
An entire chain of such islands forms because the plate carrying the volcanoes moves across the stationary hotspot inside the asthenosphere. This movement slowly carries the active volcano off the mantle plume, causing it to go extinct.
Okay, so let's pause it there. So the hotspot only forms an island directly above the hotspot. But then once the island is formed, it actually gets glued to the moving plate, or glued to the overriding plate. And whichever way the plate moves, the island moves with it. So now that first island has moved enough that it is far away from the mantle plume, that the mantle can't feed that island with lava anymore. So we would consider that an extinct volcano. But that mantle plume is still coming up, so a new island can be born.
Island grows in its place over the plume.
And now that island moves, and guess what's going to happen? That mantle plume is always going to be erupting, so a new one can come up again. So the hotspot's just always burning through the crust. And then once the volcano forms, it gets glued to the crust and gets taken for a ride. So you always end up getting a chain of volcanoes. But the only active one is the one that's directly above the hotspot.
When the plate motion changes, so does the direction of the volcanic island chain. The inactive older islands cool and subside with distance to the heat source and experience significant erosion.
So what he just said there is that as the island moves away from the mantle, from the hotspot, it cools and subsides, which means it starts to sink. And the reason that happens is cold rock gets denser. So the hotspot is less dense, so it rises. And then as it moves away from the hotspot, it cools and actually starts to sink back down. That and erosion are going to make the islands get much smaller. And that's why if you look at the Hawaiian state, the islands that make up the state, the biggest ones are closer or over the hotspot, and then the smaller islands are further from the hotspot. Those small islands at one time might have been as big or even bigger than the Big Island of Hawaii, but they're so old now that they got colder, so they started to sink back into the mantle, and the big waves of Hawaii started to erode them.
Time, former hotspot islands turn into smaller, shallow islands and ultimately become underwater seamounts.
So here you have a chain. This is exactly like Hawaii right now. All right, that could be the Big Island. That could be Maui. That could be Oahu. All right. Kauai, Nihoa. I kind of forgot all their names, but it looks exactly like the arc chain that Hawaii is known for if you look at the state. But then over time, the islands get so small that, here, right there, this one, it's no longer an island. It's now a mountain underwater. So it's a mountain in the sea. So we call it a sea
Through
mountain.
geological time, the direction of the plate motion is recorded by this hotspot track of islands and underwater seamounts.
So this is a great animation. It's the best one I've ever seen in all my years teaching, and I just discovered it this year. I've had others that are posted on my website, but this one beats them out by far. So this is a really good one. It shows how the chain of islands can form, and then even how they could become seamounts. All right, so now hopefully the shape of the Hawaiian island chain makes more sense to you, and the direction of the islands as well. Okay, so now these are your notes. So this is what's blank for you guys. So hotspots, which are also known as a mantle plume, are areas of volcanic activity that are generally, okay, not always, but generally found in the middle of lithospheric plates. The two famous hotspots in the United States fit this definition perfectly. Hawaii is in the middle of the Pacific plate, and Yellowstone Park, which I hope you heard of, is in the middle of the North American plate. Okay, Yellowstone Park is an underground volcano. All right, and it has had lots of eruptions, but it doesn't come to the surface like a mountain. Right, it's a huge magma chamber that's under the ground, and the North American plate is moving over it. So these hotspots are stationary areas of volcanic activity. And if you watch that video again, you'll see that the hotspot wasn't moving. The plate above it was. So I'll read the bullet again. It says they are stationary areas of volcanic activity. This means that the hotspot remains in the same location, even though the lithospheric plate above it moves. And then the last bullet. The result is a chain of extinct volcanoes and or seamounts. It's a mountain in the sea, increasing in age away from the active area. So basically that's saying the youngest volcano is over the hotspot, and if you draw that arrow from the hotspot through the chain, they get older. That's what I mean by increasing in age. They'll get older the further away from the hotspot. Okay, the next set of slides are just a series of pictures. This one right here is a great image showing the Hawaiian Islands. So this is your major group right here that make up our state. But if you follow this, see that? You'll see an elevated ridge on the seafloor. And then right here, there's what's known as the bend. And then that ridge goes more towards the north. And this is that long tail of islands off of Alaska called the Aleutians. And the black, darker area is the Aleutian Trench. So everything in this zone was once right here. They were all created by the same hotspot. You get a new Hawaiian island approximately every 1 million years. So every million years, a new island gets created and the old gets shifted over. New one gets created, the next one gets shifted over. So everything in this area was once here. That's crazy, right? That's how long this has been going on. So this actually allows us to figure out two different things. The direction the plate has moved. So we could see that it's been moving like this for quite some time. But sometime in the past, it moved more north. So the plate has changed directions. It also allows us to figure out the speed of the movement. Because if we know the age of one island and we know the distance from the hotspot, well, speed is distance over time. Okay? So if it's 800 miles and the island is 8 million years, then it moves 100 miles per million years. Okay, 800 miles divided by 8 million years will get you 100 miles per million years. Okay, so you just do some division. It's simple math, and we can actually figure out the speed the plate moves. Here's some more images. Oh, let me go back to this one so you understand what you're looking at a little more. This is California. And then this is Alaska. Okay, this is Japan. And so this is right in the middle of the Pacific. Okay. So these next two images are similar. This one on the left is just more of a close-up. So you have your Hawaiian chain, and then that's your Emperor chain. And obviously we call it the bend because it's obviously the chain has bent. It was going one way, and then it bent and went another way. Okay, so here is the same type of image, actually, but they gave you the names of the islands or seamounts, and they also took a caption. And so everything in this dark blue is the islands that make up the state of Hawaii. You actually learned about another famous Hawaiian island, but you didn't realize it was actually part of Hawaii. You should have learned it. I don't know if Mr. Laspinuso or Ms. Durney got up to it yet, but a famous island that marked a turning point in World War II called Midway Island. Okay, I think there was a movie recently about it. So Midway Island is right in the middle of the Pacific, or the middle of the front between the war front between America and Japan. Okay, so it was a great island that both countries kind of wanted control of to switch the balance of power. So it was a very strategic island. So was the state of Hawaii as a whole, which is why the Japanese bombed Pearl Harbor. Okay. So here's Midway. It's actually a Hawaiian island. It's 27.2 million years old. What does that mean? It means 27.2 million years ago, this island was where the big island of Hawaii was. So that's what I mean. We could figure out the speed of the movement. So if we know the distance from here to here, and we know the age, you take that distance and you divide it by 27.2 million years. And you can actually figure out the rate of plate movement. How fast has the plate been moving? All right. So we can figure out speed and direction. Two very important things. All right. The next slide is the rest of the notes. So why are hotspots important? I just answered them. And here's a hotspot showing plate A, B, C, volcano A, B, C, and D. And they're telling you that C is 8 million years old. Well, if C was where A is, and the rate of movement hasn't changed, do you think you could figure out the age of B and the age of D? Well, some of you might be answering it already. I would say B is 4 million years old. I can't write on this slide right now, but you can write on it. Once again, if you wanted to, here, bring it up into Google Keep, save to keep, see, click on it. Oh wait, go to the bullets, open and keep. Click on it one more time, move me out of the way, and then you can go to edit with that little pen. Okay, so let me turn the pointer off, sorry. This is the direction the plate has been moving. So if this is 8 million years old, this is probably 4 million. And since they all look evenly spaced, I would say this is about 12 million. So it allows you to make predictions based on motion and based on speed. Okay. So let's go back to the notes. These are the last couple of things you have to write down. Why are hotspots important? Because first bullet, they allow geologists or scientists to determine the direction a plate is moving and if the plate has changed direction. And the second thing they allow geologists to determine the speed the plate is moving and if it has changed speeds. Right. So that's today's lesson. All right, fill in the notes. We'll go back and fill them in again. If you want to play around with the Google Keep and draw and write on the images like I've been doing, you don't have to share those. Those could be for your own notes. You should do that as well. And after you write all the notes, turn it into me onto the Google Classroom. Okay, and tomorrow there'll be a Google Form assignment on this information. All right, have a great day.